Welcome back everyone, Patrick here, and moving on to another question dealing with factoring by taking out a binomial common factor. So we went through a video before this one where the expressions were a little bit easier to deal with. So when I'm going through this, I'm assuming you watched that video. And if you didn't watch it, if you're not following along on the website, if you're watching this on YouTube, you can go to the description box. There's a link to the website where all of these videos go in order, and I highly recommend you going in order because a lot of times there's a lot of carryover from previous videos, and this is going to be one of those examples. So in the previous video, what was happening was we wouldn't have to manipulate these initially. I think there was one example where we did, but for all of these we're going to have to, because notice here in part A we got like y minus 3, but over here we have 3 minus y. Now if this was y minus 3, then we could just take out the y minus 3 right away. We'd be left with 6x minus 5. But unfortunately in this case we can't do that. What we got to do is we got to work with either this factor or this factor in order to convert it to be the same as the other one. So what I'm going to do is I'm going to take this 3 minus y and I'm going to convert it so it's y minus 3. Well, they're never going to be equal, but we can change the format of this where one of the expressions is going to be y minus 3. And what we could do is we could take out a negative 1 from here. And if we take out a negative 1, what would we be left with? Well, we just divide everything by negative 1. Basically, all of these signs would change like that. And then negative 3 plus y, that's the same as y minus 3. And so 3 minus y is the exact same as negative bracket y minus 3. I just took out a negative 1 from this. And so now notice y minus 3, y minus 3. So if we do this in order to fully show the work, you could put this on the side. This is like side work over here. And then we'll have 6x, y minus 3. Then we'll have negative 5. And then this 3 minus y, we converted to this. It's like negative 1 times this. So let's fully write that out like this, right? This 3 minus y changes into those two brackets. And then from here, what we can do is we'll have 6x, y minus 3. Negative 5 times negative 1 will give us positive 5, and we got a y minus 3, like that. And now notice we could take out that y minus 3. Now we have a binomial common factor. And we'd be left with 6x plus 5. Now the solutions to these kinds of questions, a lot of times teachers' textbooks, they won't even show this step, this negative 1 and negative 5. They'll just go straight to this step, right? But if you're confused with how to go from here to here, that's basically what happens, right? There's that negative 1 we're taking out, and then you're multiplying these. And for all of these, I'm going to show the full work of what we are doing. Okay, so you got to manipulate this a bit first in order to get that binomial common factor, and then you could take out the binomial common factor like we were doing in the previous video. So let's move on to part B. So we got 5x, x minus 5 plus 5 minus x. So again, x minus 5, 5 minus x, those are not the same, but we can make them the same because this 5 minus x on this side here, we could take out a negative 1, and when we take out a negative 1, we'd be left with negative 5 plus x, and then that's the same as x minus 5. So 5 minus x, negative x minus 5, those are the same things. So 5x, x minus 5, this stays the same, but now this 5 minus x, there's like a plus 1 here by the way, this 5 minus x we're rewriting as this. So what we would have is plus 1, this plus 1 here, and then this bracket, it's going to be those two brackets. So we'll have negative 1 and x minus 5, like that. So we'd have 5x, x minus 5. 1 times negative 1 gives us negative 1, x minus 5, like that. And now notice x minus 5 is common. We could take that out. And we're left with 5x minus 1. So that ends up being the final answer for part B when we factor it by taking out a binomial common factor. Now moving on to part C, we got 2x squared times 3x minus 2y minus 4y, and then in bracket 2y minus 3x. So as you can see, same thing here. It's basically a negative in the middle, but the terms are switched. So we got to take this 2y minus 3x, and we could take out a negative 1, and basically the signs would change like before, and then just rearrange these two like that. Okay, so 2y minus 3x is the same as negative bracket 3x minus 2y. So rewriting everything here, minus 4y, let's keep that as is. Then we got the negative 1. This bracket is changing to these brackets. I got a negative 1, 3x minus 2y, then 2x squared, 3x minus 2y, negative 4y times negative 1 gives us positive 4y, 3x minus 2y, like that. And now notice, same binomial common factor, which is nice. That's our goal. So let's take that out from both of these. So we'd have 3x minus 2y. And what would we be left with? 2x squared plus 4y. Now this here, we're not actually done with it yet, because what you want to check, and I should have mentioned this actually in A and B, which I didn't, is once you have these factors, you want to see, can you factor further? Because it has to be fully factored. And notice that from here we can't take anything out, but notice from this bracket we could take out a 2 from this bracket. 2 is a common factor between 2 and 4. And so if let's actually work with that expression on the side. So what would happen if we take out a 2? Notice we could only take out a 2 because the x variable is not here, the y variable is not there. So there's no common variables. But a 2 is a common factor. If we take out a 2, divide this by 2, divide that by 2, we'd have x squared plus 2y left. Okay, so this bracket factors into those two brackets. So we'd have 3x minus 2y, and then we'd have 2 bracket x squared plus 2y. And then to make this look nicer, usually you put single expressions in the front. And we end up with that right there. Okay, so there's an extra step in this one, and you always want to check for all of these. Can you take one of these brackets and can you factor further? In the previous ones, you couldn't do that, even though I didn't mention it. I should have. But if you look at them, you can't do it. But sometimes you can, like in this particular example. All right, so this here ends up being the final answer. Now in part D, this one's going to be kind of unique because we got 5x, x minus 4 minus y. Over here, 12 minus 3x. So notice before, at least they were looking similar in A, B, and C. And here, this x minus 4 and this 12 minus 3x, they totally look different. But there is a way to actually take this and convert it to that. So if we take 12 minus 3x, what we can do is we can actually factor out a 3 from here, right? Because 3 is a common factor in 12 and 3 is a common factor in 3. So if we take out a 3, what would we be left with? 4 minus x, like that. And now notice it's getting closer to being x minus 4. And so from here, 4 minus x, how do we convert to x minus 4? Well, we could take out a negative 1 from the 4 minus x. So we would put the negative 1 with the 3, so we'd have negative 3, and then it'd be negative 4 plus x. And then negative 3 would end up being x minus 4. We could just rearrange that bracket right there. And now notice we got that x minus 4. So with this kind of expression, what you want to do is actually take out a negative 3. And once you take out a negative 3, you get that x minus 4, which would be a common factor. So this bracket here is the same as both of those brackets multiplied. So writing that out, we'll have negative 3 and then x minus 4. This bracket, all we changed was this bracket. We change to those two brackets multiplied, and we showed the work right there. And from here it becomes the same kind of question. Let's continue it here. We'll have 5x, x minus 4, negative y times negative 3, positive 3y, x minus 4, like that. And now notice we could take out an x minus 4, and we're left with 5x plus 3y, like that. And then, as I mentioned in the previous one, you always want to check, can you take anything further out from these factors? Can't take anything further out from here. Can't take anything further out from that factor. All right, so this ends up being the final factored expression. Right, so just a couple other examples of where we're factoring by taking out binomial common factors, but these were a little bit tricky because there was some initial manipulation that you had to do to the expressions in order to follow that same process.